Welcome to Brain Vision.
Once again, we have a new problem. So there's a child that's moving on a sled, so parallel to the x-axis. So they're moving in the positive direction, and their mass happens to be 10 kilograms. It's frozen surface. So this is a frozen surface, like a pond, probably no friction or minimum friction. And so there's a variable force based on a specific diagram. So it starts at 0, goes all the way up until a maximum level of 10. So this is the maximum force on it. The y-axis is f of x in newtons, and then the x-axis is the centimeters, or rather the meters, the displacement. This is 12. This is 8, and this is 0. The midpoint is like 5. So that's how the force is changing. There's a child on a sled and moving on a frozen pond in the x direction. The work done would be force times distance, but then x is a variable force, so it's changing. The first part of the question is like, what's the total work done? So part A, we want to find out the work done between 0 and 8 meters. So x1, x is 0 to x is 8. Okay, x is 0 to x is 8. That's what we want to find out. If you can recall from your math classes, this would be the base and this would be the height. So the area of the triangle is 1/2 base times height. And we connect that area to the work done. And the reason for that is work done is force times distance. The distance is on the x, which represents the base, and the force is on the y, which represents the height. So if we find the area of the triangle, it means that we're able to determine the work done from x equals to 0 to x equals to 8. So then work done, the initial work done would be 1/2 times the base, which is x, let me call this x1 and this one x0. X1 minus x0, that's the base, times the height, which is 10 newtons. 10 newtons. And so this becomes 1/2 times 8.0 meters, because x0 is 0, so we cancel that out, and then times 10 newtons. That gives us 40 joules. That's the work done from x equals to 0 to x equals to 8. The second part of the problem, well, the first part we got 40 joules. That's the total work done in the first part of the problem. The second part of the problem, we're supposed to get the work done between x1, which is 8.0 meters, to x2, which is 12.0 meters. So once again, we use the area of the triangle, okay, to get the work done from x1 to x2. Or we could say x2, I can call this x1 to x2. So that's 1/2 times the base, which is x2 minus x1. This is the base, times the height. The height stays the same at 10 newtons. So this becomes 1/2. x2 is 12.0 meters minus x1 is 8.0 meters, and then times 10 newtons. And so this becomes 1/2 times 4.0 meters times 10 newtons, which gives us 20 joules. That's the work done in the second part of the triangle. So this part right here, from 8 meters to 12 meters, with the height representing the force of 10 newtons, and the x is in meters. The final part of the problem, we want to find the total work done. So work total would be the work done in the first triangle, which is from x0 to x1, plus the work done in the second triangle, which is x1 to x2. We already had the first part, which happens to be 40 joules, and then plus the second part, which is 20 joules. So the total work done will be 60 joules. I hope you enjoyed the problem. Feel free to send out any questions or comments, and make sure you have a wonderful day. Okay, thanks. Bye.